Okay, so for the last lecture of 8.3, we're going to talk about other cross sections on page 412. Okay, and we have example 8, a mathematician's paperweight. Mathematician's paperweight, where the paperweight is going to be made, and we're going to draw this in 3D here. So we have y and we have x. And the graph that we're using here is y is equal to 2 sine x. So this guy here is y is equal to 2 sine x. And we're going to make a paperweight that takes from here, and we're going to go ahead and make it a semicircle here, right? So we're going to have a bunch of these semicircles that go through and then come down. And that's actually better drawn on page 412. On the left-hand side, figure 8.4, it shows each one of those cross sections, okay? So what do we have? We're going to have a volume, or we're going to have the area, right? We're going to have the area, cross-section area. What's the cross-section area here? The cross-section area, the y here is what? This is 2 sine x, right? From here to here, this bottom part is 2 sine x, right? So the radius of this half circle looking thing is going to be what? Sine x, right? So sine x. So the volume of this half of a disc, I guess, half of a disc is going to be what? This squared pi, because that is, if it was a regular complete disk times the dx, right? But it's only half of that, right? So because we're only using the top half here. So it's that divided by 2, and we're going from 0 to, this would be pi, correct? We're going from 0 to pi, 0 to pi, 0 to pi, right? 0 to pi. Okay? So it's going to look like that. So we're going to get what? We're going to get pi over 2, 0 to pi, sine squared x dx. And looks like the book just nint this. We don't actually have to nint this. We can actually do this, right? If I asked us to do this algebraically, you would do what? We would go pi over 2, and we would use the trig that says this is this. We could use that, right? We're going to get 0 to pi 1/2 minus cosine 2x over that dx. So the first one is simple. Antiderivative is that. What's the antiderivative of this? Would be negative sine 2x over 4, right? Because if I want to take the derivative of this, I'm going to get cosine 2x. Then I have to do the chain rule. The 2 comes out, so in order to account for that 2, I have to divide it by 2. That's why it becomes 4. Okay, and we go from 0 to pi over 2. If I put pi in here, I get pi over 2. Pi goes in here, it becomes 2 pi, which is 0. And then when I put the 0 in, this guy becomes 0, and this guy is also 0 also. So there you go. Your answer is simply pi squared over 4. And that's the same thing that the book got. Okay, so that's how you would run that. So this is kind of interesting in the fact that you're not rotating anything, but you have to be able to analytically, logically look at this and say, come up with an expression of whatever shape you're going to have here. Okay, and that's what we did over here. Okay. And then last but not least, we have Cavalieri's volume theorem. Okay, if you look over page 413, if you have the same cross-section area, but you kind of tilt it around like they have in the book in figure 8.35, it's still the same, right? It's the same volume. In other words, if you look at that as a bunch of CDs that are stacked on top, you can move it, you push it in a little bit like you would push like a Jenga stack a little bit in, right? But the volume is still going to be the same. And that's what Cavalier theorem is. Okay? And with that, we will call 8.3 done.